Oops. Anybody need help typing it in the calculator? Now, really, 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 really tiny, tiny letters. Make sure you see RAD. RAD means radians. Okay, go ahead and finish filling in your table. And when you plot your graph, you'll notice that you have that inner loop. about, what is that, number 3? 5? Number 3. All right, go ahead and start working on the next one. Now notice that for number 4, we're using the same points. But notice how these are the same. All right, because they're the same, we call that one a heart. It's going to look something like this one. All right, so I'll give you a few minutes to type it in, and then I'll show you the rest of the table. So this is the longest part of the project, but again, you'll be working with a partner, so it'll go faster. So here are the points that I got. So 0, we're going out to 4. And then we're coming in. And like the 0.6 and the 0.3, I mean, you can't really, some of the points, you can have it in your table. You don't have to put a point at every single pin. Sorry, I said that backwards. You don't have to put a pin at every single point. So it's kind of a judgment. So I can kind of see how it's forming the heart. Now it's coming back. Okay, so now let's talk about the next graph, which is called a lemniscate. So again, it's up to you. If you have a chance to look closer at the projects, you'll notice that like they just determined which ones they wanted to do. So you don't have to do a lemmathon if you don't want to. It's kind of up to you what you want to do. The main thing is, can you transfer it neatly to the board? So now let's talk about a lemniscate. So this number here, first of all, if you do a cosine, I want you to notice that it's going to go horizontal or vertical. But if you want it to be at a slant, you have to use a sine. Now this is the one with the square. So when we type this in our calculator, we are going to type it under a square root. And because we're going to type this in under a square root, there will be some errors in our table. So if you get an error at a certain angle, don't include that in your table. So just for the process of time, we'll go through the first quadrant. So 0, pi over 6, pi over 4, pi over 3. Let's just start with that. Now, when you type it in your calculator, because how do you solve? In order to solve, you would take the square root of both sides. So typing this in your calculator, you're going to type in the square root of 4 cosine 2 times, and then whatever angle. So in this case is 0. Close the parentheses. And then you're going to do it again. Square root of 4 times the cosine 2 times pi over 6. Close the parentheses. So take a moment and type in those first 4 points. So pi over 3, you should get an error. Who got an error for pi over 3? So I would not include that in my table. So I'm going to go ahead and plot these first 3 points. So at the 0, I'm at 2. Because remember, the square root of 4 is 2. So that's the longest or furthest I'm going to go is to r equals 2. All right, pi over 6, I'm about 1.5-ish. And then I'm back at 0. That's half of one of my wings. So now let's go over to quadrant 2. Now I'm noticing that I got an error at pi over 3. So that means I'm probably going to have an error at 2 pi over 3. So I'm going to skip 2 pi over 3 and go right to 3 pi over 4 and 5 pi over 6. And again, if you don't recognize that and you type in 2 pi over 3 and get an error, that's fine too. Just don't put it in your table. It's fine. So I didn't even type in 3 pi over 4 because I knew that was 0. But I did type in 5 pi over 6 and pi. And then I typed in 7 pi over 6. And then I also typed in 11 pi over 6. So 5 pi over 6 is 1.4, so that's about here. Pi, we're at 2, which is symmetrical if you look at it. So I realized that in order to finish this lemniscate, I really just needed a point here in my table and a point here. So I only added 7 pi over 6 and 11 pi over 6, but I knew both of those were going to be 1.4 because I needed to fill in my lemniscate. And that is my graph. For number 6, what is the square root of 25? 5. So this one is going to go out to r equals 5. So it's going to be a little longer. So again, and is this one going to be slanted or up or horizontal or vertical? It's going to be a slant. So just for the sake of time, I'm going to give you the points to type in. Go ahead and start typing that in. And you're going to get a lot of repeats of the same numbers. All right, and so we're going to skip over 7 and 8 today, and we'll do that one tomorrow because roses take a little bit more time, but spirals are easy. So we're going to skip to the last page and look at question 9. All right, so a spiral is the only polar graph that does not have a sine or cosine. And all you're doing is typing in the angle, okay? You're just typing in the angle. Now, this graph has a radius of 5, okay? So I just put angles in my table until I got to a number, to the highest I can go without going over 5, if that makes sense. So in your calculator, if you type in R, well, okay, you don't need to type in -0. We already know the first one is 0. And then for the second one, type in -pi/4. And then you're going to type in -pi/2, -3pi/4, -pi. And your numbers are going to get bigger and bigger and bigger. So I kept going until I reached something that was as high as I could go without going over 5. So for pi over 4, I got negative 0.7. So that means I'm going backwards to almost negative 1. And I probably could have put in some more points in between. I just did every 45 degrees, but it would have probably been better if I added in my 30, 60s. It would have been a better spiral. All right, pi over 2 is going backwards.